Hello everyone, myself Mr.S.A.Utage, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology, Solapur. Today we are going to discuss about the electrical machines, that is electrical motors and generators. At the end of this topic, student is able to understand essential concepts and working of electrical motors. Let us discuss some basic fundamentals of electromagnetism, that is how magnetic field is induced with the application of electric field. Here Maxwell corkscrew rule. If we rotate the screw in clockwise direction such that the advancement of the screw indicates the direction of the current, then the direction of rotation of the screw will indicate the direction of magnetic flux, which has been mentioned over here. Second, right hand grip rule. If the current carrying conductor is gripped into the right hand such that thumb indicates the direction of the current, then the curved finger will indicate the direction of the magnetic field or magnetic flux. The direction of the induced magnetic flux will depend upon the direction of the current. If the thumb is moving away from us, if the direction of the thumb is away from us, then the curved finger will be clockwise. Hence, we can say that the direction of the flux is clockwise. And if we hold the right hand such that the thumb is towards us, then the curved fingers will be anti-clockwise, will give the direction of the induced magnetic flux. So this is about the straight long conductor in which the current is moving in a straight line manner and the flux induced are circular in nature. So flux throughout this length of the conductor will be a concentric in nature. This arrangement is called as the solenoid. The construction of this solenoid is a coil is wound on a magnetic material and the current is passed through the coil. Refer this diagram in which you will find the arrows shown across the every winding of the or every turn of the coil. This direction of arrow indicates the direction of the current. So in this case, that is in case of solenoid, the direction of the current is circular and the flux induced are in a straight line manner. So on the left hand side there is a N pole, on the right hand side it's a S pole. So flux induced will escape from the north pole, that is from left side of this magnetic material. They will travel through the air as a medium and they will reach to the right side, that is at the S pole, and through this magnetic material it will reach, they will complete their closed path at the north pole. The difference between the straight long conductor and this arrangement solenoid is the magnetic field induced is greater than a magnetic field induced in the straight long conductor. That's why we are using the arrangement of the solenoid. So in this way, with the application of electric field, magnetic field is induced. There are two types of magnets. One is the electromagnet and another is the permanent magnet. In electromagnet, the magnetic field will be present only when there is the flow of the current. That is, the magnetic field will be present only when the electric supply is there. If we remove the electric supply, then the magnetic field will get removed. In case of permanent magnet, there always exists an N and S pole associated with it, indicating the presence of the magnetic field or magnetic flux. Fleming's left hand rule. If we stretch first finger, middle finger and thumb in such a way that they are mutually perpendicular to each other, such that the first finger indicates the direction of magnetic field and the thumb indicating the direction of the motion of the conductor, and the middle finger will indicate the direction of the current. See, this is used to determine the direction of the force, the middle finger, the forefinger and thumb of the left hand. The middle finger gives the direction of the current flowing through a conductor. Forefinger indicates the direction of the magnetic field present, and the thumb gives the direction of force acting on the conductor. This rule is used in the motor. So in this case, input is the electrical energy and the output is the mechanical energy. Fleming's right hand rule. If we hold the right hand such that thumb, first finger and the middle finger are perpendicular to each other, then the thumb indicating the direction of the conductor, first finger indicating the direction of the magnetic field, then the second finger or middle finger will give the direction of induced current. So it is used to determine the EMF induced in a conductor. That is, input is the mechanical energy and the output is the electrical energy. This rule is applicable for the alternators or the generator, whereas left hand rule is applicable to the electrical motors. Lenz's law. The direction of induced EMF is given by Lenz's law. According to this law, the induced EMF will be acting in such a way so as to oppose the very cause of production of this. That is, mathematically we can mention Faraday's law of electromagnetic induction and Lenz's law as E is equals to minus n into d phi by dt. d phi by dt is the rate of change of flux linkage with the conductor, n is the number of conductor and negative sign is the according to the Lenz's law. This induced EMF will produce the current. This induced current will set up the flux which will oppose the main flux. This is what the Lenz's law. DC generator. Mechanical energy is converted to electrical energy. There are three essential requirements and they are: conductor, that is the motion of the conductor is required, then the presence of the magnetic field is required, and the mechanical energy to give the motion to the conductor. Here you can see the diagram on the right hand side of this slide, in which the presence of the magnetic field is mentioned by N and S pole. So flux are shown by the arrows, red colored arrow moving from N pole to S pole. In the middle part of this N and S pole, the conductor is moved such that it will cut the magnetic flux. Due to the motion of this conductor, there is a cutting of the flux and the EMF is induced. This is the working principle of the generator. Whenever a conductor is moved in the magnetic field, an EMF is induced. DC machine. You can see here the commutator field winding and the armature winding. Sectional view, again same has been mentioned over. Commutator part, field system and armature system, both field system and armature system will have the windings which are separately excited by the DC current. What construction of DC generator? Field system, armature core, armature winding, commutator and the brushes. Field winding, this is the actual photograph of the field winding which is wounded on a outer stationary cylinder. Rotor and rotor winding. This is the middle part on which a conductor is mounted on as an armature assembly. They are shorted at the end so that the current can flow through this shorted conductor. Working principle of the DC motor. Here you can see a single turn coil having two conductors shown, one at the S side and another is at the N pole. These two conductors are excited by the DC current through the commutator and the carbon brushes. So on the left side conductor, the current is moving inside to the conductor, whereas N pole conductor, the current direction is exactly opposite, that is coming outside. Here there exists the interaction of the two magnetic flux. One is the straight line flux moving from N pole to S pole, and another is the circular flux due to the current flowing through straight long conductor. And due to this interaction of the two set of flux, force is exerted on these two conductors. On the S pole conductor, the force is exerted upward, whereas N side conductor, the force is exerted towards the downward, and the torque is developed, and finally there you will find the mechanical action of this conductor. This is the Fleming's left hand rule, we already discussed. Interaction of main field flux with the armature field flux. As I told you earlier, there is a interaction of the two set of flux. One is shown on the left hand side, a straight flux moving from N to S pole due to the presence of the magnetic flux, and on in the middle figure you will find the circular flux. So circular flux and straight long conductor straight flux will interact with each other, so that the left side conductor upper side there will be a unidirectional flow of the flux. So the force is exerted from the top side. So right side conductor, the two flux are opposite to each other. Left side flux, two flux are in the same direction. The force is exerted upward. This is the working principle of DC machine. Same is been explained as it was explained for the generator. Field system, it is for uniform magnetic field within which the armature rotates. Electromagnets are preferred in comparison with the permanent magnet. They are cheap, smaller in size, produces greater magnetic field. This armature control commutator. Carbon brushes are used in DC machines because they are soft materials. It does not generate spikes when they contact commutators. So these are the classification of DC motors: self-excited, then separately excited, then shunt, series motor, compound motors. What is the formula for EMF of a DC motor? Here let flux phi is the flux per pole, Z total number of conductors, P number of poles, A number of parallel paths, N armature speed in RPM, EMF generated is EG. So EMF equation we can derive as flux cut by one conductor in one revolution is P into phi. Flux cut by one conductor in 16 seconds is P phi n divided 60. So number of conductors in each parallel path is Z by n. So induced EMF can be given as P phi n Z upon 60 into A. DC motors are important in many applications. Major applications are elevators, steel mills, rolling mills, locomotives and excavators. DC series motor is suitable for both high and low power drives, for fixed and variable speed electrical drives. This type of motor has simple construction, also it is easy for design and maintenance. So because of high starting torque, this motor uses in the chips, toys and automotive applications such as air compressor, lifts, elevators, winching system, electric traction. Other applications are cranes, air compressor, lifts, elevators, electric traction, winching system, hair dryer. These are the application of DC shunt motor, wiper, automatic windscreen, drills, conveyor, fans, boring machines. These are the references. Thank you.